explore this groundbreaking theory. To understand the holographic universe, we need to start small, really small. We're talking about the tiniest scales imaginable, where the very fabric of reality begins to reveal its secrets. String theory, a leading contender for a theory of everything, proposes that the universe isn't made of point-like particles, but of tiny vibrating strings. These strings are the fundamental building blocks of everything around us. Just like different vibrations of a guitar string produce different notes, different vibrations of these fundamental strings create all the particles and forces we observe. Each vibration pattern corresponds to a different particle, much like musical notes. Now let's jump to black holes, those cosmic monsters with gravity so strong that nothing, not even light, can escape their grasp. These enigmatic objects challenge our understanding of physics. Here's where things get really interesting. Black holes have a property called entropy, which is a measure of disorder or randomness. This concept is crucial in understanding the nature of black holes. The more information a black hole swallows, the higher its entropy. This means that as black holes consume matter and energy, they also absorb information, increasing their entropy. Physicists discovered something astonishing. A black hole's entropy is proportional to its surface area, not its volume. This was a groundbreaking revelation that changed our understanding of these cosmic giants. This is counterintuitive. Imagine stuffing information into a box. You'd naturally think that the amount of information it can hold depends on its volume. You'd expect the amount of information to depend on the box's volume, right? This is how we usually think about storage and capacity. But black holes behave differently, suggesting that the information they contain is somehow encoded on their two-dimensional surface, like a hologram. This idea hints at a deeper, more fundamental principle of the universe, where reality itself might be a holographic projection. This discovery led to the mind-blowing idea that our three-dimensional universe might also be a kind of hologram. Perhaps all the information about our reality, including us, is encoded on a distant two-dimensional surface, and we're just perceiving a projected three-dimensional image. Think about it like this. Imagine watching a three-dimensional movie. The characters on the screen seem to have depth and move in 3 dimensions. But in reality, the movie is just a projection of light onto a flat screen. Similarly, our universe might be a projection of information from a distant surface that surrounds us. This doesn't mean that our world isn't real, just as the characters in the movie are still real images. It suggests that our perception of reality as three-dimensional might be an illusion, a consequence of how information is processed in the universe. Now, you might be wondering, if the universe is a hologram, does that mean it's not expanding? This is a fascinating question that delves into the very nature of our reality. The answer is no, the universe is still expanding, and the holographic principle doesn't contradict that. In fact, it provides a unique perspective on how we understand this expansion. Think of it like inflating a balloon with a picture on its surface. As the balloon expands, the picture stretches, but it's still the same image encoded on the surface. As the balloon expands, the picture stretches, but it's still the same image encoded on the surface. This analogy helps us visualize how the universe can grow while maintaining the information on its boundaries. Similarly, the holographic universe can expand while the information encoded on its surface remains constant. This means that the data on the cosmic boundary doesn't change even as the universe itself grows larger. The holographic principle suggests that space and time, the very fabric of our reality, might not be fundamental but emergent properties. They could be the result of deeper, more intricate laws. They could arise from deeper, more fundamental laws governing the information encoded on the cosmic surface. These laws might be the true foundation of our universe. Just like the rules of chess determine how the pieces move on the board, these fundamental laws could dictate how space, time, and matter behave in our holographic universe. This perspective opens up new ways of thinking about the cosmos and our place within it.